Hello everyone. We are revising reflection. Note down these questions on spherical mirrors. It's a concave mirror. Radius is 20 centimeter. Incident rays arrive in this form. Such that intersection of these incident rays takes place behind the mirror at a distance of 5 centimeter. Find out at what point these rays are going to meet after reflection. After reflection, where on the principal axis these rays are going to meet, that's what you need to find. Let's see how many of you can answer this simple part. Put on this. Look here. Focal length is r by 2. This is the concave profile. That's the center of curvature. This point is pole, and you know that pole should be considered as origin. If this is origin, center of curvature is on the left side, that means R with sign will be minus of 20. This is the part basically saying that radius is 20 centimeter. When you need to find focal length, you have to decide on which side center of curvature lies. So this is coming minus 20 by 2, which is minus of 10. Now these are what? Incident rays. And intersection of incident rays gives you what? Object. So this position is object. Object means you now have the value of u. U is what? Plus 5. To the right of origin, and therefore u is what? Plus 5. And I'm asking you v. When I ask you that at what point these rays are going to meet after reflection, basically I'm asking you value of v, because intersection of reflected rays is going to give you position of image. What is the formula? 1 upon f equals to 1 upon v plus 1 upon u. F is minus 10. We have no idea of v. Unknown things should be used in physics without any sign. V plus u, which is 5. This gives us 1 upon v as minus of 1 upon 10 minus of 1 upon 5. That is minus of 3 upon 10. That gives us intersection at this point. after reflection, rays are going to meet at this position, which is called position of the image, and this distance is coming what? 10 by 3. This is 1 upon v. So v is what? Minus of 10 by 3. V is coming minus of 10 by 3. Position wise, you will say that on the left side of pole at a distance of 10 by 3 centimeter. Do you understand this question? Yes or no? Now tell me, what type of object do we have in this system, real or virtual? And what about the image? This image is real or virtual? Write down this in the comment box. Good. What is the concept? Anything behind the mirror, anything is what? Virtual. Light rays cannot exist behind the mirror, and therefore things are what? Virtual. What is behind the mirror? Object, and therefore it is what? Virtual. Anything in front of a mirror is what? Real. So this image therefore is what? Real. In front of the mirror, light rays can exist, and therefore everything is what? Real. In this setup, it's the image which is in front of the mirror and therefore is what? Real. Now notice one more thing. As long as object is behind the mirror, that is virtual object. If object is virtual, that means u part is positive. When you shift this u to this side, this term will be always negative. Focal length is always negative. If object is virtual, 5, 6, 7, doesn't matter. 5, 6, 7, whatever it is, when you shift, it becomes what? Minus. So V is always going to be what? Negative. That means we have a short answer type question. What happens if object is virtual and mirror is concave? And the answer is what? Image in that case is always what? Real. Write down this statement. If object is virtual, and we have a concave mirror, then image is always real. And lies between pole and the center of curvature. This is something which is very easy to visualize. Every time you draw a normal on this mirror, that this is the normal shown in red. That's a normal. So if this is the incident ray, reflected ray definitely is going to meet between C and P. So remember this information and note down and draw the normal also in this figure. Note down this. It's a convex mirror. This is the object. Height of the object is 4 mm. It is at a distance of 15 centimeter from the pole, and radius of the mirror is 30 centimeter. Find out position of the image. It's on the left or is on the right side. First thing, it is above the principal axis or below the principal axis. Second thing, and the third thing is, what about the size of the image? It is an enlarged image, increased size, or diminished image, reduced in size. So find out everything about the image: real, virtual, size, position, and orientation. Note down this, should not take more than 40-50 seconds. Look here. Focal length is r by 2. Where is center of curvature? On the right side. This is pole, which is origin. Center of curvature is on the right side, and therefore r should be taken positive. The focal length is coming 15. Put here 1 upon 15, 1 upon v plus 1 upon u. Now some of you directly use u as what, 15, and then they cancelled 15 and 15 and are saying that image is going to form at infinity. I don't know how can you commit such a silly mistake, because I just in the previous example told you how to take u, r and things like that. This is the object which is on the left side of the origin. Things on the left side means u is not 15 but is what? Minus 15. So this u is minus of 15. That gives us 1 upon v as shifted here, 1 by 15 plus 1 by 15, and your v is coming 15 by 2 centimeter. V is coming positive. That means image is going to form right at this place. This is the position of image. Now, Distance from pole to image is coming what? 15 by 2 centimeter. The moment you say image is behind the mirror, it immediately becomes what? A virtual image. So this image is what? Virtual. The second thing I asked you is size. For size, we use the magnification formula. Magnification formula is HI upon HO, which is minus of V upon U. With lenses, this is minus and this is plus. In mirrors, this is plus, this is minus. Remember this. Now, we need to find HI. What is HO? If things are on the left side, U will be negative. But they are above the principal axis, which is above the x-axis. And things which are above the x-axis are what? Positive. And therefore, this is 4 millimeter minus of V, which is coming 15 by 2 divided of U. This is 1 by 2. HI is coming 2 mm. Remember, you don't have to convert millimeter into centimeter because this thing is in centimeter. This is also centimeter. Centimeter cancelled, and your HI automatically will be in what? Millimeters. This is your HI, which is coming 2 millimeter, and you can notice that HI is coming positive. Right at this place, this shown with broken lines is your image, and its height is what? 2 mm. Now, we have got a virtual image, reduced in size, diminished, and it is on the same side of the principal axis. That means it's called an erected image, upright image. So, image is on the same side of the object. If object is like this, you will find the image is also on the same side. So, reduced in size, erected, virtual. That's what the answer is. Note down this and then we'll write a statement. Now, notice this part. If object is real, that is on the left side, it's a real object. If object is real, U will be negative. So when you shift this thing over here, they both are now positive. Focal length for a convex mirror is always positive on this side. If object is real, U is negative. When you shift it, it becomes what? Positive. And therefore your term of V is always what? Positive. That means what? For a convex mirror, if object is real, image will be always what? Virtual. First thing. Second thing is, if V is positive, negative sign is of the formula. If V is always positive, U is negative, then negative is always what? Positive. That means your magnification will be positive. That means object and image, they will be both on the same side of the principal axis. Either both are up or they both are what? Down. That's what an erected image. And the last thing, if you are looking at this number 1 by 15 plus 1 by 15, this is something like a parallel combination of resistors. Parallel combination of resistors 1 upon R1 plus 1 upon R2. And I hope you remember a statement. In parallel combination, R total is always smaller than the least value of R1 and R2. There are several resistors in parallel combination. The least resistance present in the combination, your total will be even smaller than that. That means this is what focal length part, this is what magnitude of U, mod of U. So when you add something like this, whatever be the value of V, it will be less than what? F, as well as less than what? U. If you wish, you can write under this, V will be less than F, V will also be less than what? Mod of U. That means if V is less than U, your magnification M will always be less than what? 1. If V is less than U, then your magnification, which is positive, is always less than 1. That gives us what? Diminished image. Now, write down the final statement. For a convex mirror, if object is real, then image is always virtual, erected, and diminished in size. As long as you have a real object, you will find that you've got a virtual image which is diminished in size and is erected. Now this is something which you can easily remember also, and which in itself is another short answer type thing. You must have seen that on the side mirrors of a car, they have written that objects in the mirror are closer than they appear. You must have seen this notice sort of written on the mirror itself, that whatever you are looking at in the mirror is closer than it appears. So first of all, the shape of the mirror, the side mirror of a vehicle, that shape is what? Convex. And in that convex shape, whenever you see things, they are always what? Erected. If you have a bike, suppose the marker is the bike, if a bike is coming like this, you don't ever see that in that side mirror that bike is running like this. So it always looks erect. First thing. Second thing is, when they say that object in the mirror are closer than they appear, so basically you are looking at the image part. Object is that vehicle, and whatever you are seeing at is the image thing, and that image is what diminished. Now our brain, what it sees that the vehicle behind the car, your car, has a reduced size, and to our brain it appears that if it has a reduced size, then its distance from the car, your car, should be sufficiently large. But that is not the case. Why? Because the object is closer, but you are looking at the image, and that image, since is reduced in size, it gives a wrong perception to our brain that things are quite far behind, but they are closer than they appear. So, using this information written on mirror, side mirror, you can always remember these three things. Note down this information, this information. We have a concave mirror. This is the center of curvature part. This is the focal point. There are three regions in this, between F and P, between C and F, and between C and infinity. Tell me everything about this type of an object which is placed between center of curvature and focal point. Everything means, what about the image? Virtual, real, diminished, enlarged, erected, inverted, things like that. For a general position of an object between C and F. Now, you also have homework. You will investigate the same thing if I place an object between F and P, and if I place an object between C and infinity. But right now, I want you to investigate everything if an object lies between C and F. What type of image do you see? Real, virtual, inverted, erected, diminished, enlarged? Answer this. Look here. How do we investigate the whole thing? Let's say distance of the object from the pole is mod of u. It's on the left side, and therefore you're going to write u as what? Minus of mod u. If this is 5 centimeter, then this is 5, but what is u? Minus of 5. This focal length, its distance is what? R by 2 mod. R is negative. Center of curvature is on the left side. This distance is mod R. Distance of center of curvature from the pole. So what the setup says? Setup says something like this. Mod of u is greater than mod of r by 2 but is less than r mod of r. This. And now tell me, is this also correct? This thing is correct. What about this relation? Is it correct? Yes or no? Write down fast in the comment box. Now some of you are saying yes and some are saying no. 5 is less than 6 is greater than 4. What about minus 4, minus 5 and minus 6? Can I still say this? The answer is no. Minus 5 is greater than minus 6 and is smaller than what? Minus 4. Basic thing. And therefore, this is not the correct relation. What is the correct relation? Correct relation is that when you remove the mods, r, u, r by 2, everything is what? Negative. And therefore, correct relationship is that r by 2 is greater than u and is greater than r. Distance wise, r by 2 is less than mod of u, distance wise. But when you take proper sign, r by 2 is greater than u. Just don't worry about this thing. It looks like that r by 2 is greater than r. Yes, because r is negative. Now, with this much information, let's find out v. 1 upon v is coming 1 upon f minus 1 upon u. 1 upon v. This gives us v as f u upon u minus f. 1 upon v. So what is v coming? Fu upon u minus f. Now, what is f? A negative number. What is u? Another negative number. Focal length is r by 2 is negative. U is on the left side and therefore is negative. R is on the left side, center of curvature is on the left side and therefore is negative. So your f and u both are negative, divided by, this is u and this r by 2 is basically what? Focal length. So let me write down r by 2 as f. F is greater than u is greater than r. Now, if you say f is greater than u, f is greater than u, then u minus f is a negative number. F is greater than u and therefore u minus f is what? Negative. The whole thing v is coming what? Negative. V is negative, that means image is on the left side. This is the origin. V is coming negative, image is on the left side. So the moment you find that V is coming negative, This information tells you that your image is virtual. So we have decided about the image, real or virtual. Magnification HI upon HO is minus of V upon U. U is negative. V, we just found that is also negative. Negative, negative, negative. Your magnification is coming what? Negative. If M is coming negative, then it tells us that we have got an inverted image. We have got an inverted image. The last thing about the size part. I'm removing this information. If you have note down that, look here. M magnification is minus of V upon U. So what is V upon U? V upon U is F upon U minus F. F upon U minus F. V divided by U. F upon U minus F with a negative sign. This M is now what? This is 1 upon 1 minus U upon F. So what I have done? Divide the whole thing with minus F. Take minus F common. So minus F upon F is what? 1, and this becomes what? Minus of U upon F. I hope you can see this part clearly. 1 upon 1 minus U upon F. Now, this magnification term, if you look at this magnification term, look here, is what? 1 divided by 1 minus, what is U? A negative number. What is F? Another negative number. U is a negative number, F is a negative number, and therefore whatever you are subtracting, just look at this analysis. U upon F. U is a negative number, F is a negative number, and therefore whatever you are subtracting is a positive thing. And then the most important part, this positive number, U upon F. Look here. U and F, if you go for these things, so when you go for the ratio of U and F, U is say 10 centimeter, that way it will be much more easier for you to remember. If this is 10 centimeter, then F thing, this part is what? 4, 3, something like that, less than 10. So if you go for the ratio of U upon F, what do you get at this place is something which is 1.1, 1.3, 1.5 type of thing. But it cannot be 2.1 2.2, 2.3 type of thing. Why it cannot be 2.2 and 2.23 type of thing? Because this U has another limitation, that it is mod wise less than magnitude of R. So when you go for this part, it tells us, or if you are good, then maybe you will understand with the help of this one line. Let me erase the whole thing, and you will understand the whole thing here. This is what mod U. If I divide the mod U part with F, mod of F, mod of F, mod of F, I can always do that without changing any of the equality sign. Reason being, I am dividing the whole thing with what? Something that is positive. Now, remember this U upon F term, U upon F term, we have already decided is what? Positive. U is negative, F is negative, and therefore you go for U upon F, or you go for mod U upon mod F. They are basically what? Same. So this is mod U upon mod F. Mod U upon mod F, now you can see, is less than what? Mod R upon mod F. What is mod of F? Mod of R by 2. What is this? 2. So whatever you get here cannot exceed 2, should be less than 2. How does it matter? Why do we need to know this? Number coming over here can be of 1.1 type, 1.2 type, 1.9 type, but it cannot be of 2.1 type. If this number is something which is less than 2 and greater than 1, let me use a number, say 1.5. The moment I write 1.5, it becomes what? 1 upon minus of half, which will give me minus of 2. Negative sign, I have already decided that image is going to be what? Inverted. I am interested in the mod part too. So what I get, that M is something which is always greater than 1. If M is greater than 1, mod of M is greater than 1, then it tells you immediately that your image is going to be enlarged. Whatever image you are going to get is going to be an enlarged image. It's coming from this. Now, suppose somebody takes 1.5 instead of 1.5, and if you do not decide this part, that the ratio of U and F should be less than 2, if you don't go for that, then somebody takes 2.5, then things are quite different now. 2.5 minus 1 will give you what? Minus 1.5. Denominator will be greater than 1, and in that case your mod of M will be less than 1. So why did we do this whole analysis? So that we can prove denominator, forget the negative sign, denominator is always less than 1. If denominator is always less than 1, the whole thing will be more than 1. Forget the negative sign. That gives us an enlarged image. Well, tell me, do you understand this part regarding enlarged image? Because other things are quite easy. The only conceptual thing was how to decide whether you get an enlarged image or diminished. Are you comfortable with this? Yes or no? And we can do one more thing. What is the other thing which we can do for this magnification thing? Just note down everything fast. Take a screenshot. Now, we could have done for the m part something like this. We don't want to use numbers like 2 or 3. Look at this. This is f greater than u greater than what? R. What is R? R is 2f. R is 2f. Which is what? This is f greater than u greater than f plus f. 2f is made f plus f. Why? Because I need u minus f. So this tells me that u minus f is greater than f. U minus f is greater than f. Now, if I say u minus f is greater than f, then look carefully. I need the ratio of f upon u minus f. F upon u minus f. F upon u minus f. If you shift this thing u minus f over here, at the same time you need to remember what? It's a bit mathematical and therefore I prefer numerical values, but if you can understand this analysis, then it is also good. F is greater than u. This tells us that u minus f is less than 0. Also that it appears and looks good to you. Let's write down this way. It is telling you that u minus f, shift f there, is less than 0. So once I say u minus f is less than 0, this u minus f is a negative term. Now again maths tells us, if I shift u minus f over here and I simply write 1, then it will be wrong. Why? Because I need to change this. Reason being, u minus f term itself is negative. That means this is now this. So f upon u minus f is basically greater than 1. And why do I need f upon u minus f? What is m? F upon u minus f is a negative sign. I'm interested in what? Mod of m. So this f upon u minus f is basically what? Mod of m. M is negative, minus of 2. Mod of m is what? Mod, remove the negative sign. So you are left with f upon u minus f, and we have proved that this f upon u minus f whole thing is nothing but m, not m, mod of m, which is greater than 1. But you need to be careful with all these plus and minus things. Now, it's an important result for you to remember. If you have an object which lies between center of curvature and focal point, then your image is first of all virtual, enlarged, inverted. How many of you understood this analysis? If you understand this part, also write down yours. Well, it seems some of you are not comfortable. It's not a difficult thing. You can always practice on your own. You can always practice these things. But I have asked you, if you say that 10 is greater than 5 and you shift 5 over here, then everything is good. But if I say minus 10 is less than minus 5, which I told you, if I put a negative sign, I need to change the sign. So minus 10 is this, and now if I shift, but I continue with the same thing, if I shift minus 5 and I do not reverse the whole thing, then I am getting what? 2 less than 1, which is not correct. So whenever you divide by a negative number, you need to change. You need to change. That's why we did this. Note down this much. And I've given you the homework. Place an object between F and P. Investigate everything. Place an object between C and infinity and investigate everything. And then send me your answer. Note down this much and then you can leave. Thank you very much.